We are here at South Pole Station with the AGOS project lead down here, Bob Melville. And Bob, why don't you tell us a little bit about what you do with the project? What's your role?
Okay, well, I share the engineering responsibilities with Andy Stillinger, who you already met. And I've been doing the project 7 years now. I have a non-teaching position at New Jersey Institute of Technology, half-time, to support this work. I have a general responsibility for all the engineering aspects of it. Kind of roughly, I do a little more of the data and scientific materials, whereas Andy works on the power system, but we share those things. So our goal is to get the stations running and deliver science data as reliably as we can, and we are making slow progress on that. I inherited the project from a previous group who had it at Berkeley, and they transferred the responsibility to NJIT, and I took over the lead role as the role as the lead engineer for this project.
Okay, Bob. So can you tell us a bit about what got you interested in this line of work to begin with, and then how did you find yourself in the coldest place in the world, Antarctica?
Well, I worked for 16 years at Bell Laboratories. I had a great time there. The second year I was there, I made the acquaintance of a very famous geophysicist named Lou Lanzarote, and one of the people who worked for him, Carol McLennan. The phone company was interested, starting in the 1970s, on the effect of the Earth's magnetic field on transatlantic telephone cables, which can be quite severe. So they started a project under this direction of Lanzarote and Carol McLennan to instrument the globe with magnetometer stations. And I just caught my imagination the second year I was at Bell Labs, but I really could not afford to take off any length of time from my main career. So in 2002, I got laid off from Bell Labs, finished my career there, and decided what else could I do with my life. So I had this opportunity. I was still, reasonably good health. So I, after a brief teaching position, I took the plunge and applied to the United States Antarctic program to work for a year at the South Pole as what they call a winter over science tech. So indeed, I was part of the 05-06 winter over population here. We had 63 other people. It was an amazing experience. We hit negative 107 degrees Fahrenheit. And I guess I've always had an interest both in practical engineering, but also sort of an adventure component. And I like the work here because it strokes my adventure gene, but it's adventure with a purpose. I mean, there's a certain amount of physical effort and risk involved, but I feel like I'm actually making a contribution by supporting these science projects, and that's a very important aspect of the whole thing for me.
So did you have an interest in electronics and adventure as a child?
Oh yeah, I've always been interested in backcountry skiing and winter mountaineering, that kind of thing, and practical electronics. So this was a perfect combination. For me, this is the closest I will ever come to serving in the space program. I'm too old to be an astronaut, but the experience at the winter over the South Pole was really a close second. I mean, you fly around in a spaceship, you wear a spacesuit, and you live in a space station. That analogy is not too far stretched. Plus, the food is much better. So, okay. During the winter, the woman who cooked for us was just superb. It was unbelievably good food. So,
oh, fantastic. So, one last question. Space weather. Why should we be concerned about space weather and the interactions between the sun and the Earth's magnetic field?
Well, there's still an open-ended research question there. I mean, understanding the interaction of the Earth's magnetic field, the ionosphere, the solar wind, coming up with a good computer model of that is an open scientific question from a pure research standpoint. But again, the reason I'm down here is because the phone company observed when there was a large transient in the Earth's magnetic field caused by an event on the sun, they would see a 12 kilovolt, a 12,000 volt pulse at the end of one of their transatlantic cables. So imagine you're sitting there talking to your mother with a 2 or 3 volt signal, and here comes a 12 kilovolt signal riding on top of it. You have to design the equipment properly to deal with that kind of thing. Early satellites, when they put into low Earth orbit, did not work as well or as long as they thought they would because there was a misunderstanding early on of the space weather environment. A direct applicable deliverable of our research has been to improve the engineering of satellites so that that's really no longer a problem. A large transient could take out the power grid. There's precedent for that. We don't know exactly what would happen to the communication satellites in low Earth orbit, even today, if they were hit with a very large transient event. So there are a couple of practical examples of this kind of thing.